And now, please join me in welcoming Dr. David Hirschberg, an immunologist and biotechnologist who's a principal investigator with the Center for Urban Waters and who will be speaking about blue-collar biotech in Tacoma.
See, my first slide didn't work. Hey, thank you, everybody. It's an honor to be here. I'm very excited about a biomedical program. My background is biomedical research, and I've been kind of here a couple years in Tacoma waiting for this to happen, so I can justify what I do. So this first slide is basically my affiliations. So I also work for the Army. So the Army funds a lot of the work I do, and so I acknowledge them. I'm a kind of a geek for them, and so I do a lot of technology evaluation, development of point of care and wearable technologies. So I thought, since we're talking about biotechnology, I should really talk about this One Health approach. And it's something that I'm trying to train the Army to come up to speed on, and also how we go after this. So this is nothing new to the Seattle community, but we need to bring it down here to Tacoma. But really, what is the reason why diseases emerge? And so again, we were going to talk about pathogens and samples, and I'm not sure if I got another microphone here or too far away. I really am interested in disease, and that's my interest as an immunologist and a person who's building point-of-care devices. So really, what are the genetic and biological factors, microbial adaptation and change, the physical environmental factors, climate and weather, economic development, land use, and all these ecological factors. So we really can bring in the environmental factors into this, and that's what I've been playing with the last few years. We have changing ecosystems. So when you think about disease, you really have to think about all these things in the environment. And we're an urban-serving university, right? But we also are very globally focused. And so these interactions are happening right in our ecosystem, but they're also very much in the world. So here's just something I want to remind you. We are reproducing on this planet. So up until really quite a while, just very recently, we've been a fairly steady state, not a lot of impact on the environment. Here's the Black Death right here. I threw that in for you, Ann. And just there, so we started going a little corrective there, but ever since then, we've been going up. And so that puts a lot of stress on an environment, as most people who study the environment know. So here it is, crowding. So this is people who are working on urban solutions. This is kind of a ghetto in Brazil. So whenever you have high population living in a very tight area and poverty, these are the mix you get. These are things that are looking for. This is Tacoma. Trade. We travel more than any other time in the history, and so we have a lot of people moving around. So from a pathogen standpoint, there's a lot of fresh meat, basically, good real estate. And so Tacoma is involved in this. We have goods coming in and out. We have a trade system that takes us in and out of this area. So there is lots of opportunities for outbreaks and pathogens. So I've been kind of working in my garage, waiting for things to come up. So we started this thing called the Readiness Acceleration and Innovation Network. And so we want to do blue-collar biotech, really, take these high-tech things, bring them here, and really bring into our kind of Tacoma DNA what is possible. So we created this kind of collaborative approach. So we're very open. We want to work with everything. So I work with anybody who wants to work with me. So City of Tacoma, local biotech companies, local investor community, of course, the University of Washington and all of the rich resources and students there. Joint Base Lewis McChord, often underlooked. It's just a jewel down here that has Madigan Research, our hospital, and then a multi-care health system. So the combined patient base from there alone is 600,000 people in the network. So a lot of opportunities for study. So we created this acceleration network, and this is really an open network. It's really anybody from the community can be involved, and we're really, students can come and be involved with it. But the idea is really this hands-on urban environmental, medical, and global biotechnology training. So we really want to put this together. We want to create kind of a core laboratory to support basic research of faculty and student-led projects. So this is something we started up in one of the IPZ lab here in the science building. And we do biotechnology contract work, mentoring programs, supporting research needs of companies and local community. And of course, my interests really are in advanced biomarker monitoring, core for area hospitals, JBLM, and area agencies, Department of Health, for instance. So you can do this in the environment. The technologies we have, like gene sequencing and that, can be used both in the environment and in the hospital. You can be trained in both. So environmental biomonitoring, we support urban waters. And then we want to be a bioresource laboratory interacting with the community, artists, entrepreneurs, active military veterans, community colleges, and high schools. So if I left anybody out, that was a mistake. You can come and talk to me. And because I'm in the military, I'm very interested in dual-use research. So there's many words for that that's used. You think of things as good or bad, but you can also look at military technologies being used and tested in the environment. And so are they functioning as biomedical? So those are iPhones there. They're fieldable devices that you can take measurements on, but you can also use those in a hospital environment, and we can test them. So we want to evaluate these technologies, and I'm interested in getting programmers involved in this, engineers. Can we build this better? Can we do point of care? Can we exchange ideas, create these things? And so we want things to work in real world conditions, and then I want students that really can transition with these projects. So they can either go to DOD or DOE labs. One of my students went to Multicare last year. She did an internship at Fred Hutch. And so that was Haley Overbilling. If you don't know her, she did excellent. I've got Ryan, who's one of my other students. You saw his poster tonight, so I'll show some of his stuff. Katrina did an internship out at Army. So I'm looking really to take students and mentor them and then get them jobs and transition them in the community. And hopefully they'll take on students. So back to my biology approach, I'm into stage strategies of overlapping technologies. So bring things to our lab, let's test them out, and let's see how they work. And so we do a lot of mass tag work, we do array chips, and now we do shotgun sequencing. So you can do all these things, they overlap for pathogen, they all have sweet spots, just like you create a toolbox in your garage. And you grab a tool, not everything is a hammer, right? You need other tools. So they're overlapping tools. And then really validating with old school techniques like real-time PCR and consensus PCR. Good solid stuff. I can leverage the military. So Edgewood Chemical Biological has this unique infrastructure. They do really scary things, but they also know a lot about the cultures and everything. And you can work with simulants that are not dangerous and practice on. But alarms still go off if you make a mistake, so we can really train people correctly. So they focus really on detection, which is really important in environmental or medical, protection, which is another really important thing for responding and protecting yourself from anything that might be a threat. And decontamination, which if you've lived in Tacoma, you know all about, right? We live in a very toxic environment. And so there's biology that can be taking care of that. So they do a lot of cool stuff. So working with fieldable genetic analysis through nanopore sequencing, these are sequencers that you can carry with you in the field. And we have one up in the lab, and we use this to now, and so students can be trained on this. This is an example of a colleague of mine, Stanley Langevin. So he's really looking at host and microbiome. So you've heard of the microbiome, right? So this is all the organisms that live on you and in you. We have the technology here. In fact, Ryan just made a library that we can actually test what's on you, in you, and basically get all that information out. So all the organisms that make you up, you're not you. You're only about 10% of you. There's a lot of other people along for the ride. But in the environment, too. The environment has a microbiome. We did a project with Taylor shellfish. Up until then, they'd really looked at genetic reasons why their colonies were crashing, and also looking at physical changes in the environment, which were very important, like temperature change and pH change. But we were interested in what was going on in their microbiome. So they tend to grow things in artificial environments. They take them off the beach. And so we were wondering if they left the microbiome behind maybe and changed it, because they would get these horrible crashes. Everything dies, smells really bad for about a quarter mile around there, but you don't know what was going on up until that point. Once everything crashes, you pretty much know something's going wrong. So we're looking at early markers with that. And we had students in that. Katrina played part of that. Path Tracker is an interesting project. It's an NSF-funded grant that we have. And we're looking at equine pathogens, equine respiratory pathogens. So next to people, horses travel. They're the frequent flyers on planes. They travel more miles than any other animal, so only humans more. So a horse can be in Saudi Arabia one weekend, California the next, Churchill Downs. They just travel all over. They're athletes. They're packed into places with a bunch of strange people. They're under stresses. Many are now subjected to drugs, and they have incredible stresses. They get sick. You only need a note from a vet to move between countries. And these things are giant bags of perfect places for pathogens to go. So we study this, and plus they're expensive. So this is an idea of a handheld device that will go into there. So Ryan spent the summer validating the PCR assays that will go on this, and then this will be a handheld phone that a veterinarian can take into a barn and make measurements in pretty austere conditions. If it works there, we might want to talk about whether we could use this on people. So that's what we're looking at, these kind of technologies. So install, read, identify, report. That's kind of just real simple stuff. The Army developed all these arrays that were made for really nasty things like VX gas and things like that. But they also work if you have beetles metabolizing. They just measure volatile compounds when they turn colors. And so they're doing all kinds of testing with this stuff. And I'm like, we have warehouses around here that are full of these things. There's people storing coffee beans. Let's get it into the warehouses and look at that. So we work with Sprague. So this is not just an internship, but it's us going to them saying, we might have a solution to your problem. And so they work with us, and we put them in warehouses, and we're looking for all these bugs and seeing if we can measure them. And you can imagine how that would be coupled into a cell phone. So low-cost chem biodetection. So how do we do it? And we can look at all these different bug warehouse beetles and come up with something. Oops, sorry. And then coupled to that, there's companies. This is a company that spun out of Weyerhaeuser, Intertechnics, and so they developed a sampling system. They're TSA funded. They can look for explosives, but the particles are very similar to bacteria. So you can actually use this to suck huge columns of air into your tester and then look for pathogens. So we can put that now in the warehouse. I can send another student down there and play with that. So I work with some vets out in West Kansas and West Texas, and there's a lot of dead animals hanging on the wall there. That's Texas. And they're looking for basically looking to do vaccine stabilization. So we came to them with an idea of eliminating cold chain. Can we test their vaccines to see, because if in 114 degrees in Kansas, vaccines go off bad. They're put on ice, sometimes they go bad. And so we can test them. We have a system that we can test there. And these cows, it's life and death. It's $1 million industry, but I'd rather test it here before I give it to my soldiers. So again, our Tacoma microbiome census, we're doing this project. Danny Litwin was part of this, and she's a tattoo artist, and she got permission to go to a lot of the tattoo parlors and look in the waiting room, the bathroom, what pans, things, and just survey the pathogens or good guys that are in those places. And so we're looking at that. And then we do a project on wearable technology. So we do things with wearables. So again, working with some of the programmers here and developing software. I'm interested in these kind of interface. So right now we have a project we're trying to get through an IRB where we would equip people with Fitbits and really start making measurements. Real simple questions like, can we correlate quality of sleep with health? And then as technology gets more sophisticated, we can layer those technologies in. So, the idea is how many things could we put together? And when I think about wearables, you can do really simple things. Like, for instance, here's a soap crayon that you can put on kids that get them to wash their hands by doing that. And so this is this point of care kind of things. Here's a wearable RFID that tracks vaccination of babies. So in austere environments, you can collect a lot of data and use it. So these are very simple. These are not ours, but I like these kind of innovations. And then again, working with the Joint Base, there's a lot of rehabilitation for wounded warriors, and you can see the crossover between the Army and healthcare in this. And these technologies are becoming available, and you have to evaluate them. And how do you build systems to do that? We could build labs to do that. We could start companies to do that. So I'm going to put in a shameless plug for a lecture series I have. So I bring my friends to the area, and I feed them, and I apply them with all kinds of liquids. Some of them, not all of them drink, but we build these interactions so that students can now start interacting with people from the outside. And really, I bring these people here to show them Tacoma. They're wondering, what am I doing? Why did I come back here? And so now I can show them the quality and the grit that we have here and really put them to work and really get them thinking about outside the box about what kind of projects we could do and what kind of collaborations and where I could send my students once we do that. So I just wanted to kind of acknowledge again some of the people that really have contributed. These are all students. They're still contributing. And I like this quote, and I wanted to put it out. So in theory, there is no difference between theory and practice, but in practice there is. And I really think this is important to really hammer this home as we build this new school, is that you really need to get dirty, and you need to get into the fecal matter, really, and get those pathogens and really understand this. And I think that is really part of that Tacoma spirit, and it's part of UWT. So thank you.